Through the years, Ontario Power Generation has been committed to upgrading and maintaining its hydroelectric plants to produce more clean, renewable electricity for the people of Ontario. For over a century, Ontario Power Generation and its predecessors have invested in the power of water to help fuel the growth of the province. Hydroelectric stations all use similar processes and equipment to generate electricity. Water collected above the station is channeled downhill through large tubes towards a type of water wheel known as a runner. The water passing by the runner spins it, which in turn rotates a generator that creates electricity. By the 1970s, some of Ontario's hydroelectric stations had been faithfully generating power from water for half a century. Unfortunately, the original turbine runners were vulnerable to a unique phenomenon called cavitation, when water vapor bubbles created inside the turbine collapse and create shock waves.
If that happens, it will create pits and eventually holes in the turbine blades, and then the runner either has to be repaired or replaced.
Engineers began to explore the options available to maintain the aging hydro turbines into the future. They concluded that modern runner design technology could reduce costly maintenance and offered the added potential to produce more power from the existing plants. The turbine upgrade program was born.
It takes a bit of faith in your design engineers to go out and take a perfectly good turbine runner and scrap it and put in a brand new one, which is a very expensive proposition, on kind of a technical say-so.
Transferring the ideal design from the computer to the real world is a long and technically challenging process. Some of Ontario Power Generation's runners are almost 7 meters in diameter and weigh tens of thousands of kilograms. Yet they must be precisely manufactured to incredible tolerances of less than the width of a human hair. Long before the replacement runner is delivered to the station, highly skilled Ontario Power Generation maintenance trades are on site to overhaul other components in the unit and prepare it for the upgrade. Even though the stations are constructed with enormous volumes of concrete, there is minute settling and shifting over time that must be accounted for when aligning all the parts for installation of the new runner. A laser guidance system is used to line up the embedded parts to within a few thousandths of an inch to ensure that the turbine operates smoothly for decades. When everything is ready, maintenance crews carefully move the runner into position, and the new unit is bolted into place. The primary advantage of the turbine upgrade program is the additional energy that is generated from the same amount of water at the existing stations.
And I think all of us are very proud of what we've been able to contribute, and to know that our contributions will continue to produce clean, reliable power.